Hello and welcome to Algebra 2 Lesson 51. In this video we're going to learn about complex fractions. So again, we talked about this back in Algebra 1, and for the majority of stuff with regard to rational expressions, we've already seen it before. So how would we simplify something like this? Well, first and foremost, we know it as a complex fraction. That's a fraction where there's another fraction in either the numerator, the denominator, or both the numerator and the denominator. Well, we really have two methods to kind of work with this. The first method would be to attack kind of the numerator and denominator separately, then to do kind of the main division. So this would be your main division, or your main fraction bar. Let me kind of make that arrow a little better. So what I could do here is I could say, okay, well, I need a common denominator, so I can multiply this by 3 over 3. And so this would give me what? I would have 25 plus 75 over 9, and then this is over 10. 25 plus 75 is 100, so you would basically have 100 over 9. You think about this as divided by 10. And you could do 10 over 1 if it makes you more comfortable with the process, because what do? We take the first fraction, which is 100 over 9, and we multiply by the reciprocal of the second fraction, which is 1 over 10. So I can see that I can cancel this with this, and I get a 10. And so I end up with what? 10 ninths. So what's the other way to kind of do this? Kind of the faster way, at least in most scenarios. Well, you can find the LCD for all the denominators involved. Okay, so for all the denominators involved. So I have a 9, I have a 3, and I have a 10. So what's the LCD? Well, 9 is what? It's 3 times 3. 3 is prime, and 10 is 2 times 5. Okay, so what I would do is I would include each different factor up to the largest number of repeats it appears in any factorization. So here I have 3 times 3, here I have 3. So it appears twice in the factorization of 9, only once here. So my LCD would include 2 factors of 3, or 9. Then times, I have 2. Doesn't appear anywhere else, so it just goes in there. Then times 5, again, doesn't appear anywhere else, so it just goes in there. 9 times 2 is 18. 18 times 5 is going to give us 90. So what I would do is I would multiply the numerator and denominator of the complex fraction by 90. Now this is where it gets a little complicated, because you're like, well, what's the numerator and denominator of the complex fraction? Again, if this is the main division, I can multiply this by 90 and this by 90. And so what's going to happen? Let me just erase this real quick. Again, I'm just multiplying by 1. And let me make these into one multiplication symbol. And 90 over 90 is 1. I'm allowed to do that. So what would this give me? Well, if I distributed this 90 to this 25 over 9, the 90 would cancel with the 9 and give me a 10. So I would basically have 10 times 25, which is 250. Then plus, I do the same thing again. 90 times 25 over 3. 90 would cancel with 3 and give me 30. 30 times 25 would give me 750. Then this would be over 90 times 10, which would be 900. So what does this leave me with? It looks like it's not going to work out, but it will. 250 plus 750 is 1,000. And this is over 900. Well, if I just cancel 2 zeros, I end up with what? 10 ninths, just like I saw with the other method. So really, it doesn't matter what you use. It's just a matter of what you're more comfortable with. Now, this is a very easy scenario to deal with because we're working with just regular fractions. When we turn up the heat here, and we look at these complex fractions that have rational expressions in them, it's going to be a little bit more tedious. So let's look at the first scenario here, where we have x squared over 5 plus 25 over xy plus 2x over 25 over x squared. So this is your main division. This is your main division. So if I want to, I can go through and I can get common denominators here. I can do the addition, and then I can do the division with this. But I'm going to tell you right away, the LCD method is generally, this isn't every time, but is generally going to be faster when you're doing these with rational expressions. It just is. So let's just focus on that. what is the LCD for all denominators? I've got a 5, so throw that in there. I've got an xy plus 2x. This could be factored into what? X times the quantity y plus 2. So we'll multiply this by x times the quantity y plus 2. And then this one is just x squared. I've already got an x here. Do I need x cubed? No, I do not. Because if I broke this down, this would be x times x, and this would be x. So I'll go with the largest number of repeats. So all I'm going to do is make this x squared. Okay? Please don't make the mistake of saying, okay, I've got one x here, and I've got an x and another x, so this is x cubed. It doesn't work that way. Again, the largest number of repeats, in this case, that's going to be 2 of them. So my LCD is what? It's just 5x squared. I'll put these together. 5x squared times the quantity y plus 2. So if I just multiply the numerator, which is this guy right here, I'll put it in parentheses, 5x squared times the quantity y plus 2. If I multiply my numerator by this, and my denominator by this is my denominator, I'll be able to just simplify this. All right, so let me put my multiplication symbol, and now we're ready to go. So I will have what? I will have x squared over 5 multiplied by 5x squared times y plus 2, right? That quantity. You can see that these 5s would cancel, and so what I'm left with is x squared times x squared, which would be x to the 4th power. Let's go ahead and write this as x to the 4th power times the quantity y plus 2. Now, then I have plus. I'm going to multiply this times this. So we'd have 25 over, in factored form, that's x times the quantity y plus 2, times we have 5x squared times the quantity y plus 2. So what's going to happen is this is going to cancel with this. This will cancel with one of these. I'll have 25 times 5, which is 125 times x. So plus 125x. Okay, then this is over. Now, for this one, if I multiply this by this, we know just the x squared would cancel. So I'd be left with 5 times 25, which is 125, times the quantity y plus 2. Now, is there anything I could factor out from the numerator? Well, I could pull out an x, right, if I wanted to. So let's just go ahead and do that. You want to try to leave these things in factored form if you can. So if I pulled out an x, I would have x cubed times the quantity y plus 2, and then plus 125. And then this is over. So we'd have 125 times the quantity y plus 2. Nothing else I can really do to factor. Nothing I can really cancel. I just leave it like this so that it's obvious I can't cancel anything else. Well, let's take a look at another one. So we have y plus 3 over x plus 6 minus y plus 3 over x minus 5. Then this is over. We have 3 over x minus 5 minus y plus 3 over x plus 6. So for the LCD, it's going to be 1. The LCD is 1. Nothing can really be factored. We would just list things. So I have an x plus 6 here and here. So only one of those goes in when I build my LCD. Then I have an x minus 5 here and here. So again, only one of those goes in when I build my LCD. So what I'd want to do is multiply the numerator of the complex fraction, which is going to be this up here, and the denominator of the complex fraction, which is this down here, by this quantity x plus 6 times the quantity x minus 5. So this is x plus 6 times x minus 5. All right, so if I use my distributive property here, I can distribute this to this. And so what would happen here? We don't need to write everything out. This is going to cancel with this. So what I'm going to have is x minus 5, that quantity, times the quantity y plus 3. Let me erase this and this. If I did the same thing here, now x minus 5, that would cancel with this. And I'd have minus, you'd have y plus 3, that quantity, times the quantity x plus 6. Now that minus is important. I'm subtracting all of this away. You can put this in brackets if you want to make it crystal clear, or if you're good enough to remember that, you can leave it alone. But I think it'd be important here to just put it in brackets That way we don't make a simple sign mistake. All right, then this is going to be over what? So I'm doing the same process here. So this would get multiplied by this. The x minus 5, that would cancel here and here. So you would have 3 times the quantity x plus 6. Then minus, if I erase this and this would get multiplied by this. So this would cancel with this. And I would have y plus 3, that quantity, multiplied by x minus 5, that quantity. Again, we have that minus sign, so let's put it inside of brackets. Okay, so let's scroll down a little bit. Now, what should we do here? Let's go through and do our multiplication and see what we can cancel, what we can get rid of. X times y is xy. X times 3 is plus 3x. Negative 5 times y is minus 5y. And then negative 5 times 3 is minus 15. Now, I'm going to put minus, and I'm going to put my brackets there, and I'm going to do my multiplication. Y times x is xy. Y times 6 is plus 6y. 3 times x is plus 3x. And then 3 times 6 is plus 18. So then this is over. We have 3 times x, which is 3x. Then 3 times 6, which is plus 18. And then right here we put minus. And then inside of brackets, y times x is xy. And then y times negative 5 is minus 5y. And then 3 times x is plus 3x. And then 3 times negative 5 is minus 15. All right, let's scroll down and get a little room going. So what can I do here? So let me just start out by just doing this. I have xy. I have plus 3x. I have minus 5y. I have minus 15. Now this minus is going to get distributed to every term inside the parentheses. We don't want to make a sign mistake. So this would be minus xy. It would be minus 6y. It would be minus 3x. And it would be minus 18. Okay, and we'll come back and simplify that in a second. And make that a little bit better. Down here I have 3x plus 18. Then I'm doing the same thing. I'm going to distribute this to every term. Every term. So I'll have minus xy. I'll have plus 5y. I'll have minus 3x. And I'll have plus 15. Okay. So we have xy minus xy. Those would cancel. Just get rid of that. You have 3x and you have negative 3x. Those cancel. Get rid of that. You have minus 5y and minus 6y. Those would give you minus 11y. I have negative 15 and minus 18. So that's going to give us negative 33. So then this is over. Down here, what can we cancel? Again, we have 3x and negative 3x. That cancels. So we'd have negative xy plus 5y. And then 18 and 15 would be 33. So can we do anything to factor the numerator? Well, I could pull out an 11 or a negative 11. Let's just pull out a negative 11. That would give me y plus 3. In the denominator, could I pull anything out? Could I factor anything? The answer to that is no. So I'm just stuck with this negative xy plus 5y plus 33. And this is the best that we can do. Right? We could do different variations of that. We could leave it like this. I could have pulled out a positive 11 from the numerator. All kinds of things that we could have done. But really, that's the answer. So we have negative 11 times the quantity y plus 3 over negative xy plus 5y plus 33. All right, let's take a look at one more of these. Again, I think this is something that most of you already know how to do. We have 1/3 plus 5 over y plus 7. And this is over. We have x minus 6 over 9 plus x minus 6 over 3y plus 21. So 3 I can't factor. Y plus 7 I can't really factor. 9 I could factor into 3 times 3. And then 3y plus 21 I could factor into 3 times the quantity y plus 7. So what do I have here? I have a 3 here, 2 3s here, and a 3 here. So if I'm building my LCD, I would put 2 3s in, because that's the largest number of repeats, so I'd put 9 there. Then I have a y plus 7 and a y plus 7. It only occurs once in each of those, so I just got to put 1 in. So once I have my LCD, it's very, very simple. Just, again, multiply the numerator of the complex fraction by 9 times the quantity y plus 7, and do the same thing to the denominator. So we're multiplying by 9 times the quantity y plus 7. All right, so let's erase this. and we can get started. So multiply this by this. We know that 9 would cancel with 3 and give me 3. The only thing we have up here is a 1. So it would basically be 3 times the quantity y plus 7. Then plus, if I use my distributive property here, the y plus 7s would cancel. So this would cancel with this, and I'd be left with 9 times 5, which is 45. In the denominator, we use our distributive property. The 9s would cancel. You'd have x minus 6, that quantity, multiplied by the quantity y plus 7. Then plus, the next thing we'd see, we would multiply this by this. Now again, this factors into 3 times the quantity y plus 7. So what would happen is the 9 would cancel with the 3 and give me a 3, and the y plus 7s would cancel. You would essentially have 3 times the quantity x minus 6. Let me put my equals here and put equals here. And then let's scroll down a little bit. So in the numerator, 3 times y is 3y, plus 3 times 7 is 21, and then plus 45. In the denominator, x times y is xy, then x times 7 is plus 7x, then negative 6 times y is minus 6y, then negative 6 times 7 is minus 42, then plus 3 times x is 3x, and then 3 times negative 6 is minus 18. All right, so let's keep simplifying here. Scroll down a little bit more. So all I can really do in the numerator, 21 plus 45, 5 plus 1 is 6, 2 plus 4 is 6, so this would be 66. So this would be 3y plus 66 over. In the denominator, what can I do? I have xy. I have 7x plus 3x, which is 10x, so plus 10x. I have negative 6y. And then I have negative 42 minus 18, which is minus 60. So the question is, can I factor anything and cancel? Well, I know in the numerator, I could factor out a 3. So I could factor out a 3, and I would have y plus 22. Okay. In the denominator, could I factor that using grouping? In the first group, I could pull out an x. That would leave me with y plus 10. In the second group, I could pull out a negative 6. That would leave me with what? A y plus 10. So if I factor out that common binomial factor, I would have the quantity y plus 10 multiplied by the quantity x minus 6. So it does factor, but it just doesn't do me any good. I can't do anything with it. I have a 3, nothing to cancel with. I have the quantity y plus 22, nothing to cancel with. So I just leave it in factored form. You could report your answer this way, but you're kind of leaving it open to yourself. Hey, could I have factored stuff? So you want to just leave it in factored form to say, hey, there's no way that I could have canceled anything. See, here's the proof. So 3 times the quantity y plus 22 over y plus 10, that quantity times the quantity x minus 6.